good to create one for each section to make it easier for you to follow through. So the first video recording will be the remaining portion of section 8.1. We started section 8.1, polar coordinate system, today in class. We went through the construction and then the transition from the rectangular coordinate system into the polar coordinate system. And we looked at examples of plotting points, an introduction of the elements of the polar coordinate system, the design of the order pair. Now we are going to make use of all these properties and elements of the polar coordinate system into two major topics. One of them was introduced today in class, transitioning or converting an order pair that is already given in the rectangular coordinate system into polar and vice versa. And then we'll expand this into converting polar equation into rectangular equation and vice versa. While I'm showing examples from my lecture notes, I'm gonna revisit the study guide of the upcoming quiz number 6 that is scheduled for this Sunday, and then work with two of the questions of the study guide that are specifically related to converting order pairs from one system to the other and converting equations. So let me go ahead and then share my notes. Now, when it comes to my notes, I'm going to use just one file to make it easier for all of you. So, video recording notes. And then I will start section by section, specifically highlight the sections to make it easier for you to follow through with all the topics and everything that will be discussed in all three video recordings. So let's start off by converting coordinates from one system to the other. I took my time today and then explained how we generate the formulas that shows indeed connection between polar coordinate system and rectangular coordinate system. Formulas that we actually used in the past, but we did not know at that time that all of them were somehow connected to this brand new coordinate system. So one of the formulas I generated in class today was x equals cosine of angle theta multiplied by the radius r. So radius r times cosine of angle theta. This formula, as I explained, comes directly from the right triangle that is transitioned into a circle of radius r and center 0, 0, where theta is a central angle. X representing the adjacent side, and then y representing the opposite side. Now the other formula is related to the coordinate y, being r sine of angle theta. The way I generate the formulas today, we did rely on the definition of sine of theta being opposite over the hypotenuse. So this is the idea that was used. Sine of angle theta is equal to the ratio of opposite side over the hypotenuse. Now we can write this ratio as the ratio of opposite side, which is the coordinate y, over the radius. And then if both sides are multiplied, I'm going to remove this first part of the formula. And then if both sides are multiplied, so multiply by r, both sides, then we get y equals r sine of theta. In a very similar way, we generate the x equals to r cosine of theta. So let me readjust this for the function cosine. So we have cosine of theta equals the adjacent over the hypotenuse, and the adjacent is x. And then, of course, we multiply both sides by r to get coordinate x. And these are the first two formulas that will be used to convert. So I'm going to highlight in them. So these formulas are used. Use these formulas to convert r comma theta. That's a polar coordinate. We are converting this into x and y. So how this is going to work? Let's look at our first example. So convert the ordered pair. Convert the given ordered pair in polar coordinate system to rectangular. So what is given a point. So the given point is in the form r and theta. This is 3 comma 5 pi over 3. We are going to convert this into x and y. So what we do to convert, we start off by identifying r and theta. So the first coordinate of the given order pair is 3. That represents the radius r. And then the second coordinate of the point is theta, which represents the amount of a rotation, in this case counterclockwise, and that is 5 pi over 3. Now, to make things more understandable for you, 5 pi over 3 can be converted into 300 degrees if you still have a hard time understanding the difference between degrees and radians, and then have more difficulties explaining the radian measure than the degree measure. So this is what is given. Now I'm trying to take this ordered pair and then convert it into x and y, which is our normal rectangular coordinate system. So how do I do that? I rely on these two formulas. So the coordinate x and the coordinate y. So we are going to find x let's do this no color. So the coordinate x equals r, which is 3, multiplied by cosine of 5 pi over 3. Now this is where we need the unit circle. In the unit circle, angle is 300. So when you look at the unit circle, 300 is an angle in the fourth quadrant where cosine is positive. And cosine of 300 is the same as cosine of 60 degrees, which is 1/2. So I'm going to keep 3 as it is, and then replace cosine of 300 or cosine of 5 pi over 3 by 1/2. And then remember, when you multiply a fraction by a number, always is a good idea to write both in the fraction form. One of them is already in the fraction form, but you can place 3 in the fraction form as 3/1. And then if you multiply it with 1/2, now you multiply into fractions. That's altogether 3/2. So this is coordinate x. Now let's transition to coordinate y. To find the y coordinate, we are going to multiply r, which is still 3, by sine of 5 pi over 3. In the fourth quadrant, the numerical value of sine is the same as numerical value. The numerical value of sine of 300 is the same as numerical value of sine of 60, which is square root of 3/2. But in the first quadrant for angle 60, sine is positive. In the fourth quadrant is negative. So in this case, we are multiplying number 3 by, I'm going to use parentheses, a negative sign, and then write square root of 3/2. So the outcome has a negative sign because you multiply positive 3 by a negative number. Again, once again, it's a great idea to write 3/1, so change it into fraction form, and then multiply it by square root of 3/2. When you multiply a regular number by a radical form, you just place the number in front of it. So altogether, this is going to be 3, the square root of 3/2. And now we have an order pair that is r and theta converted into an order pair of the rectangular coordinate system that we write it as x is 3/2, and then y is -3, square root of 3/2. Notice one thing, this point belongs to quadrant 4, and then as you see, even the given point is point in quadrant 4, because if you measure angle theta, 5 pi over 3, that's a 300-degree angle in quadrant 4. And then the terminal side belongs to quadrant 4. So therefore, point is part of quadrant 4. So you start with a point that is in the quadrant 4, and then you stay in the same quadrant. Now there is a very similar question, in which I'm going to call it example number 2. And example number 2 is from your practice quiz 6. And let's see what the example is. It's very similar to the one that we just did. Fine. So directions are the same. I'm writing down, by the way, this is question number 3 of practice quiz 6. So directions are the same. Find the rectangular. I'm writing down the directions. Find the rectangular coordinates of the point that has polar coordinates. And these are the polar coordinates. So the polar coordinates given are -2 and then 4 pi over 3. So we do understand that r is, let's write that down, the little r equals a -2, and theta equals 4 pi over 3. So what we do in this case, I'm gonna copy and paste the previous computation and then adjust it to make it easier in terms of typing in, and then adjust accordingly based on the new numbers. Same formula. So what is given is a polar coordinate, r and theta is given. We're trying to get x and y. Formula for x is going to be r multiplied by cosine of theta. So r is -2, and cosine of theta is cosine of 4 pi over 3. So we have a -2 that is multiplied by 1/2, because 4 pi over 3 is 100 and so let me write that down. Angle 4 pi over 3, if I convert it into degree measure, that's going to be 4 times 180 over 3, or 4 times 60, so that's 240 degrees. Let's put the degree notation in there. So cosine of 4 pi over 3 is the same as cosine of 60, but it is in the third quadrant. So it's a point, it's an angle in the third quadrant. Cosine of it, it's going to be a negative number. So the same as cosine of 60 numerically, but 4 pi over 3, 240 degrees belongs to quadrant 3. So therefore, cosine and sine are both negative numbers. So what I'm multiplying in this case is -2 over 1 by -1 over 2. So the answer is positive. The 2 cancels out. So altogether, the coordinate is +1. Now let's transition into finding the second coordinate. The second coordinate is based on y equals r sine of theta. So r is the same, -2, and then sine of theta is going to be sine of 4 pi over 3. Again, an angle in the third quadrant where sine has a negative sign. So this is going to be negative, but numerically it's going to be the same as the value of sine of 60. So I only have to adjust -2 because the other number is correct. So that's going to be a -2 over 1 multiplied by a negative square root of 3 over 2. So the answer is going to come out as a positive. +2 over square root of 3 over 2. 2 cancels out. So altogether, this is square root of 3. So if I rewrite this, this is how we started. Reminding everyone, this is the solution of question number 3 in the practice quiz 6. And these are the coordinates, 1 comma square root of 3. Now you're probably wondering, is this point indeed a point in the first quadrant? I just mentioned that angle 240 belongs to the third. How come the given point belongs to quadrant 1? because of the value of r. Remember, r is the radius, it's a distance, must be positive. The minus only tells you the direction you're measuring. So you're measuring 2 units on the terminal side of theta, but not on the same direction, on the opposite direction due to the minus sign. So if you look at this point, if there is no negative sign, this should be a point in quadrant 3. But obviously, due to the sign, which is a negative sign in front of r, you measure 2 units on the terminal side of theta, but opposite direction. So therefore, this belongs to quadrant 1. So now our third example will be an example of converting, reversing the direction. So converting from rectangular coordinate system, so x and y will be given, into the polar coordinate system. So we're going to use the second set of formulas. Let me write down the directions. Convert. These are directions that you find as far as the question number 2 of practice quiz 6. So I will do one example from my lecture notes, and then one example will be question number 2 of practice quiz. So convert the order pair in rectangular coordinates to polar coordinates with r being positive. And angle theta being an angle between 0 and 2 pi. So that's the given information. Now let's see what the order pair is. So remember now the direction is reversed. So we start off with x and y. So I have an order pair, x, y. Xy is given as -3, square root of 2. Interesting example. Comma, 3 square root of 2. And then our goal is to convert into an ordered pair of the form r comma theta. That is what is unknown. We can no longer use the previous formulas, the ones that are highlighted in green, because these formulas only work when you go from polar into rectangular. So in other words, if you know r and theta and you're trying to find x and y. Now, I don't know r and theta. That's what I'm trying to find. All I know is x and y. So what are the formulas that we use in this case? One of the formulas I generated in class today was the tangent theta formula. And you may argue and say, how come you don't use sine and cosine? Because see, everything is based on what is given. What is given for me is x and y. Remember, tangent theta is the ratio of opposite, which is your y variable, over adjacent, which is x. So that's why I have to rely on tangent theta. So I'm going to use y over x to find tangent of theta. And then if I find tangent of theta, then I claim I should be able to find my angle theta. Now, if you are wondering how am I going to get r, remember where the triangle is located. The hypotenuse of the triangle is r. The opposite is the y-coordinate. The adjacent is x. It's a right triangle. So in other words, I have two sides of the triangle, x and y, or the opposite and the adjacent, and I'm trying to find the hypotenuse, which is r. So all I have to do is rely on Pythagorean identity. So that means I'm going to write r squared, that's the Pythagorean identity, is x squared plus y squared. And then if I'm using this formula, I should be able to get r. So let's see if we can do it. Let me start off by using r, because that's an easy step since we have done Pythagorean many times. So r is unknown. X is negative square root of 3 over negative 3 square root of 2. So I got to use some parentheses. There you go. And then y is simply square root of, 3 square root of 2. Remember, we are squaring these two numbers. I'm going to show the word for squaring one, and then you should be able to understand the other one. So the question is, let me square the negative 1, and then you should be able to do well with the other one. So what squaring is, and this is not the first time we do something square. Squaring is multiplied by itself. So you're going to take this expression that I have in parentheses, and then you multiply it by itself. Now, when I multiply by itself, you notice that I have numbers inside the square root and numbers outside. So you do not mix them. So you multiply outside numbers together. So a negative 3 times a negative 3 is a 9. And then you multiply the inside numbers together. So next to 9, I'm going to have the square root of 4, which turns into 9 multiplied by the square root of 4, which is 2. And the answer is 18. So this square root of 3, negative 3 square root of 2 raised to the second is 18. Now you can do exactly the same thing for the other one. And then all are you going to get is 18, another 18. So your radius square, it's going to be 18, edit 18, so it's 36. And then if r squared is 36, then r is equal to the square root of 36. Now the directions are clearly saying r must be a positive number, so r therefore is 6. So this is how we get r. Now let's focus on the second step. Now I need to get the second coordinate, which is theta. To get the second coordinate, I have to rely on tangent theta. And tangent theta is the ratio of y over x. So that's going to be the coordinate y. So what is my coordinate y? So let's go back. My coordinate y is positive 3 square root of 2. So let's plug that in. So let me pull out the ratio. And then same thing, but with a minus in front of it, that is coordinate x. So definitely you're dividing two numbers that are equally the same, but one is positive, the other one is negative. So that's going to be negative 1. Now you have tangent theta, and then I have to write this down. Tangent theta is equal to negative 1. So you need an angle theta where tangent is negative 1. The only scenario where tangent is negative 1 is the scenario where sine and cosine are numerically equally the same. So x and y, in other words, are numerically equally the same. But one is positive, the other one is negative. And then the cases where that's going to be possible are the cases where the angle is either in quadrant 2 or quadrant 4. Because in quadrant 1 and 3, both x and y share the same sign. They both are either positive in quadrant 1 or they both are negative in quadrant 3. And then if you divide two numbers that are sharing the same sign and they're both numerically the same, the answer should come out as a positive one, not a negative one. So now I need to figure out if this is going to be quadrant 2 or 4. So how do I know that? Then I go back and see where is my point, given point located. This is my given point. So where is this point located? The point x and y that is my given point, I'm going to write the comment in there. So the given point belongs to quadrant 2 because x is a negative number, y is positive. X is a negative number and y positive. Point is in quadrant 2. So now you need an angle such as both coordinates cosine theta, sine theta, which is x and y, are numerically equally the same, but one is positive, the other one is negative. Cosine is negative, y is positive, sine is positive. And that particular angle is angle 135 degrees. Or a different way of writing 135 degrees is 3 pi over 4. And then definitely I'm going to use the radian measure. So now I have both. So I have angle theta, 3 pi over 4, and then I have the radius 6. So that means my given point, I'm going to go back right there. This is how I started. So therefore, my given point will be equal to the order pair 6 comma 3 pi over 4. That's it. So now let's transition to example number 4. This is again practice this number 6. And now question 2. So let me go ahead and then write the information. So these are the directions. Find the polar coordinates of the point that has rectangular coordinates. And these are the rectangular coordinates. So I have to copy this and then adjust it accordingly. So my given coordinate now are, so this is going to be 2 square root of 2. I'm reading directly from the practice quiz. So yeah, so the second coordinate of the question 2, x is equal to negative 2. Based on the given information, if you're paying attention, this given point, and then I have to write this down because that's something that we are going to need it. So I'm going to write down the given point belongs to quadrant, and then obviously you can see it, quadrant 4. How do I know that this is quadrant 4? Because x is positive, y is negative. Point where x is positive and y negative are all points of quadrant 4. So let's see what the outcome is going to be. So we start in a very similar way. These are the formulas. So let's do R first. This is 2 square root of 2. I'm going to ask you to refer to the previous one, the way I squared this number. And this is the other one, which is a negative 2. Now, when we square 2 square root of 2, that means 2 times 2 is going to be 4. And then square root of 2 multiplied by itself is the square root of 4. Square root of 4 is 2, and 2 times 4 is 8. So once again, let's break this down, make sure that you're following me. So I'm multiplying this number by itself. So that means 2 times 2 is 4, and 4 is multiplied by the square root of 4. So this is the same as saying 4 times 2, which is 8. And that's why you see 8 in there. Plus negative 2 multiplied by negative 2 is 4. So this is altogether 12. And now we have r squared equals 12. So therefore r is going to be the square root of 12. And then if I simplify this, I have to write this as, this is your this is where you need some algebra skills with all these square roots. So this is 4 times 3, which is square root of 4, that's 2. And then 3 is going to continue to stay inside as radical 3. So far we have r equals to 2 square root of 3. Now let's look at I think I copied something wrong. Yeah, that's 2 square root of 3. Okay, so let's back off. Coordinate is 2 square root of 3, so I apologize. Let me make changes. That's 2 square root of 3. Yep, it's 2 square root of 3. So that's going to change r. Okay, we can quickly make this adjustment. So this is going to be 9, which is 4 times 3. That's 12. Okay. And then 12 plus 4, that's 16. Oh, now it becomes a different story. This is 16, and then 16 as a perfect square. So that's going to change everything. That's just square root of 4, 16, which is 4. Wonderful. So r is 4. We got r. Now let's get to tangent. Sorry about that. I don't know why I copied that as 2 square root of 2, but it is 2 square root of 3. Feel free to check your practice quiz. You have a copy of it. So now let's look at tangent. Tangent is the ratio of coordinate y, and that is negative 2 over 2 square root of 3. So it's going to be a negative. 2 cancels out. So we get 1 at the top, and then square root of 3 at the bottom. So another way of looking at this, if I'm trying, remember what tangent is sine over cosine. And this is an angle in the 4th quadrant. How do I know that this is going to be the 4th quadrant? Because the given point belongs to the 4th quadrant. That's why I started off by saying the given point is a point in the 4th quadrant. So in the 4th quadrant, in order for me to come up with this answer, I need sine to be negative. Sine is the y coordinate. And then cosine to be positive. Now, what is the value of sine that is going to create the negative 1 at the top? That's going to be 1 over 2. And what is the value of cosine that is going to create the square root of 3? So this is where I get this idea. That is going to be root 3 over 2. So if I have these two fractions and then we use that keep switch flip, then we're going to have a product of the fraction -1/2 by the reciprocal of 2 over square root of 3. And then obviously this is how you get the -1 over square root of 3. Now the reason why I'm bringing this up, because that is clearly telling you is the ratio of sine of angle. So for a sine to be 1/2, your angle must be an angle of 330 degrees, because your angle is in the fourth quadrant, and then the value of sine we know is negative, but numerically is 1/2. The value 1/2 for sine corresponds to the angle 30 degrees. So another angle in the fourth quadrant that shares the same numerical value with angle 30 degrees, which is 1/2, is angle 330 degrees. So this is sine of 330 degrees, for all of you to understand it, divided by the cosine of angle 330 degrees. So this is where I'm getting those numbers from. And sine of 330 is -1/2. Cosine is square root of 3/2. So 2 cancels out, and this is how we come up with tangent. So that allows me to get angle theta, because my goal is to generate angle theta. So what is angle theta? Angle theta is indeed 330 degrees. But if I convert this into the corresponding radian measure, this angle theta in the radian measure is 11 pi over 6. So another way of writing this, 11 pi over 6. So now I'm ready to write the point. This is where we are. So we just converted the rectangular coordinate, x and y, a point in the fourth quadrant, into a point that has coordinate in the polar system, still in the fourth quadrant, but now the coordinates are given as 4, 11 pi over 6, or you can use 4, 330 degrees. They both are the same. I can write the other one. It's the same thing. Okay, example 5. Now we are transitioning. We're still going to rely on the study guide, because there are 2 equations in the study guide that are required the conversion. But instead of converting points, now we are going to convert equations. So the goal is to write an equation using polar coordinates. And there's a variety of equations that I'm going to show, including one example that is part of your study guide. But let's start with my first equation. So the first one is you have x equals 12. Equation given in rectangular coordinate system. My goal is to convert this equation into the polar system. So how do I convert this into polar system? I'm going to rely on this formula right there. So I know that x in the polar system is r cosine of theta. And then my x is 12. So that makes r cosine of theta equals to 12. So I just substitute the product of r with cosine of theta by x, which is 12, and solve for r. So that means you're going to take this equation and then divide by cosine of theta. Same thing. You are going to divide by cosine of theta. So that's going to generate the corresponding of this equation, x equals 12, into the polar system, and the corresponding is r equals 12 over cosine of theta. Okay, let's do another one. I just showed you one with x, and I'm going to show you one with y. So this is what is given, y equals -6. So what we do to write this equation that is already given in the rectangular coordinate system. So we are going to rely on this formula. And then knowing that y is r sine of theta, we are going to let's try to make this no color. There you go. So we are going to use the product between r and sine of theta. Write this product as r sine of theta. Write this product not as equal to y, but as equal to the value of y, which is -6. And then do the same thing. So I'm going to solve this for r. So solving this for r means isolating variable r. So let me change them in fraction forms. Change -6 into a fraction form, and they both will be divided by sine of theta, because that's part of the isolation process. And then once you divide, we are going to get r equals to -6 sine of theta. So pretty straightforward. Now, let's reverse the direction of conversion. So far, I showed you writing an equation using the rectangular form and then converting it into polar form. Now, in my example number 6, I'm going to reverse the direction. So convert the polar equation to rectangular form, and then identify the type of the curve. So this will be more interesting, represented. And then, by the way, the questions that are part of the practice quiz are related to this direction. So this will be a little bit more interesting. This is what is given. I simply know r equals 15. That's all I know. So it is in the polar form. As it is, I'm not going to be able to recognize the curve that is represented by this equation. So in order for me to identify the curve, the type of curve that, or the graph that is represented, I have to convert this into a rectangle. How do I convert? I'm going to square both sides. So squaring both sides means taking this equation and then r becomes an r square because you're squaring, and then 15 square becomes 225. Now, what's the whole point of squaring? There's a reason why I'm squaring. There is a formula that I used a few minutes ago, and then I'll bring it back to you. So these two formulas right there. Why these two formulas are so important, and then I can still use them to make this conversion possible. Let's focus on this one. Let's see what r is. We know r is x squared plus y squared. And then my r squared equals 15 squared, or 225. So if I look at these two equations, I realize that I can substitute r squared by 15 to the second power. So this allows me to rewrite this equation in the form of x squared plus y squared equals 15 squared. And this is a pretty well recognized equation. This represents a circle centered at 0, 0, and radius r equals 15. So it is well recognized as a curve. If you recall the equation of the circle, I'm going to write that down. This is what we call the standard form of the equation of the circle. It's x minus h to the second plus y minus k to the second equals r to the second. Now these elements h and k represents the coordinate of the center. The center is defined by hk, so these are the coordinates of the center. And then the radius is r. Now the radius r is the 15. Now you may argue and say, I don't see h and k. They both are 0. Since they're both 0, that's why you see x squared and y squared by themselves. Because you can easily write x squared as x minus 0 squared, because x minus 0 is still x. Okay, let's do another one. And the one that I'm about to show you is part of your question number 4 of your quiz. So now I'm going to go to practice quiz. Practice quiz 6. And this is your question 4. There are two polar equations. One of them is pretty much very similar to the one that I just did. So you're going to rely on this form. If you square both sides, you're going to get r to the second equals to -4 to the second power, which is 16. In this case, we know that r squared is x squared plus y squared. By the way, this is a -5, sorry. So that should be 25. So how do I write this? Knowing that r squared equals 25, I'm going to substitute r squared by 25 and then write the equation. So the equation is x squared equals 25. So circle, centered, at 0, 0, and radius r equals to 5. And let's do the other one that is interesting. That's part of your quiz again. Now the other one, what is given is theta. That's all you have. Theta equals pi over 4. Now what makes this example very interesting? As it is, it's difficult to recognize the curve represented by this equation. We understand that this is a polar form. So convert into a rectangular form. Using, now pay attention, if theta is given, so that's what I need to use right there. So if theta is given, I need to use this. Tangent theta equals y over x. This is how the given information in the polar system connects with the rectangular. So I'm going to try to merge these two things together. I know that angle theta is pi over 4, so that tangent theta becomes tangent of pi over 4. So let's do that. So I'm substituting now theta by pi over 4 because that's what's given. And this is where it gets interesting because I know what tangent of pi over 4 is. That's tangent of 45 degrees. And tangent of 45 degrees is 1. So let's write this down to make it more understandable for all of you. So we know that tangent of pi over 4 is equals to 1. So this is tangent, let's write this in degrees. So that's going to give you an opportunity to better understand this. And that's 1. So therefore, 1 is equals to y over x. Then multiply both sides by x. So if both sides of this equation are multiplied by x, you get 1 times x so multiply by x both sides. And then do the same thing on the other side. So multiply by x. If that's the case, then you get y equals x. And that is a pretty well recognized equation. This represents the graph of the identity function. A function is called an identity function if x is equals to y. So graphically, this is called or this is known as the bisector of quadrant 1, and 3. It is a line that includes only points where x and y are equal, such as 1, 1, 2, 2, 3, 3, 4, 4, or -1, -1, -2, -2, -3, -3, -4, -4, and goes through 0 as well. So now it's a pretty well recognizable graph. So it is a line. And that's pretty much concludes your section 8.1. And then, of course, most of the work for practice quiz number 6, including all the questions 1 through 4. Now, the remaining of them will be related to section 8.3. This section particularly gives you opportunity to do some operations with numbers. But before we do that, we have to make an introduction of this section. So what is included in section 8.3? As I said, I'm going to continue to use the same copy of the lecture notes, but I'm going to do another video recording for section 8.3. So I'll split up the recording of each of the sections to make it easier for all of you to follow through. So let me save this, and then all these copies will be posted in Brightspace to make it easier for you to read through the video recording notes in addition to watching the videos. So that's going to allow you to better understand this. So I'm going to stop sharing, and then of course stop the recording.